Hey folks, welcome to the next lecture in Introduction to Chemistry. So we're going to be looking at section 8.5 today, looking at solution dilution calculations. Section 8.5. So I want to start with a figure we've talked about before, but now I want to ask a different question. How can you change the concentration of a solution? So we know what concentration is. We know that in this figure, concentration is increasing from left to right. We have most concentrated over here on the right, least concentrated over here on the left. And so if you had a solution, one of these vials, how could you change the concentration? What could you do, right? We're going to focus on two things that you could do to change the concentration. So one is, what could you do to make it more concentrated, to increase the concentration? Let's say we have this middle vial here, and we want to increase the concentration, right? So what could we do? What could we add to make it more concentrated? Well, we'd add more solute, right? Concentration is solute over volume, and wanted to increase the concentration, you can add more solute. Basically make the numerator bigger, right? The other option, just theoretically, would be to remove water, but based on the fact that we have a mixture, um, you can do that. It's called distillation, right? You can increase the concentration through distilling something. It's a little more complicated. It's doable, but easiest thing is to add more solute if possible. The If you want to go in the other direction, what can we add to make it less concentrated, more dilute, and decrease the concentration, right? What could we add here? We can't add solute. We can't remove solute. But what we could do is add more water. And of course, you know this kind of intuitively. If you dilute something, it means you add water to it. Now, the total volume, like if we had this one and we added water, right? The volume would increase. We added more water and it increased again, right? So we have a volume change, but not a solute change, and that's actually important, right? Um, that's how we get the concentration change. It's solute over solution. So if we increase the solution volume, then we decrease the total concentration. So this is called dilution, of course. And if you add water to a solution, one thing that does change is the volume, right? Volume changes, as we just said in the last slide. One thing that does not change is the amount of solute. All we're doing is adding water. So thus, as a result, the concentration changes, and it increases or decreases. It decreases, right? So if you add water to a solution, the volume changes, the amount of solute does not change. Thus, as a result, the concentration changes and decreases. Okay, that's all kind of conceptual. Let's actually illustrate this with looking at a specific unit of concentration. So let's use molarity to illustrate this. So molarity is moles divided by liters, right? So here's your question. We have a 2-liter solution that contains 6 moles of solute. What is the concentration in molarity? Okay, so we have 6 moles over 2 liters would be 3 moles per liter, or 3 capital M molar. Okay, great. Whoops, put that back. Now, if we add water so that we double the volume to 4 liters, what's the new concentration? Well, we still have 6 moles. We haven't changed that, remember? Now we have 4 liters, and so it would be 1.5 molar. All right, so let's look at what we just did. If we doubled the volume, the concentration was halved, went down by a factor of 2. There's an inverse relationship. Now, the number of moles was constant, right? But the volume changed and the concentration changes inversely according to that. Now, the fact that the moles doesn't change is important, and we're going to use that to derive an equation called the dilution equation. So let's consider some initial stock solution. We'll call it equation 1 or solution 1. And molarity is equal to N over V, where N is the number of moles and V is the volume. If we add water, the moles of the solute doesn't change, right? M and V, however, do change. So we now have a new molarity, M2, and a new volume, V2, but N is still constant. If we rewrite these two equations, solving for N, we get N equals MV and N equals M2V2. And N's are the same thing, so these two terms must be equal to each other. And so we set them equal, and we get this equation. M1VE1 equals M2V2. Or more generally, C1V1 equals C2V2, where C's are the concentrations and V's are the volumes. This equation works for any concentration unit as long as they are the same, C1 and C2, and any volume units as long as V1 and V2 are the same. So now we have what's known as the dilution equation. And C1V1 would refer to the concentration and volume of the stock solution, which would be the more concentrated one. And we will refer to the C2V2 as the diluted solution. So now we basically have 4 variables, right? And the kinds of problems that we will get will be where we'll have the information for 3 of these variables. And we can always find the 4th, right? And often students like to just start plugging numbers in and going. I like to rewrite the equations to solve for what you want before you plug in numbers. At least to me, variables seem to be easier to manipulate. And so I'd like to see students starting to do it this way. So for example, let's say that the concentration of the stock solution is unknown, but everything else is known. So that means we want to find out what C1 is, right? C1. And so we could say C1 and divide both sides by V1, and we get an equation for C1 in terms of the other 3, assuming we know those. If we wanted to solve for how much of the stock solution do we need? We have an equation for that. If we want to know the concentration of our diluted after we perform some action, that would be equal to C1V1 over V2, right? And finally, if we want to know what volume of diluted solution we would end up with given the other parameters, we can write this equation. Now you don't have to memorize any of these because you can get them fairly easily from the dilution equation. So we're always going to start C1V1 equals C2V2, figure out what you know, figure out what you're solving for, set up the equation for that, and go. All right, let's try a couple practice problems. And then we'll actually be done with this section. fairly quickly. So here's our first question. What is the concentration of a dextrose solution prepared by diluting 15 milliliters of a 2.0 molar dextrose solution to 25 milliliters? Honestly, the most challenging part in all of these questions might be um, deciphering what's what in the given question, right? What's the stock? What's the dilute? What are you solving for? Okay, so we're going to sort out what we have and what we want. So um, we're going to be diluting this solution. So this is the stock. We have a stock solution. We're going to take 15 milliliters of it. It is a 2.0 molar dextrose solution. We want to um, dilute it to 25 milliliters. And it says, what is the concentration? So the unknown would be the new concentration of the diluted solution. And so now we can strategize. That would be, sort out our variables and make an equation to solve for what we want. So C1 V1 equals C2 V2. We want to find concentration of the dilute C2. So C1 V1 over V2, right? Again, by dividing both sides by V2, we get C2 by itself. Now we will solve, right? So solving involves actually plugging in the numbers. So we have 2.0 molar times 15 milliliters divided by 25 milliliters equals C2. Notice the units. Milliliters cancels out. The volumes are both in the same unit, so that's fine. And our final answer will have units of molar. So let's go ahead and plug this into a calculator or do the math however you want to. And we end up with 1.2 molar. Now it says final thing is to check, right? Always stop and check at the end. Does this make sense? So one thing to check is units. And we already did that. It's supposed to be concentration. Units work out to be molar, so I think we're good there. And then we go and do a conceptual check, right? We diluted this solution. So the concentration should be less than what we started with. And we started with a concentration of 2.0 molar, right? We now get 1.2 molar. Great. That conceptually makes sense. The concentration went down. Okay. So that's how we can solve for the concentration of a dilute solution. Let's keep rolling along and we'll do another practice problem together. Okay, this one says, how would you prepare, so slightly different question, but how would you prepare 100 milliliters of a 0.45% half normal saline solution from a stock solution of 0.9% normal saline solution? So as always, you can pause this and answer for yourself. But let's be strategic here and work through what we know and what we're solving for. So we want to prepare a 100 milliliter solution of half normal saline from a concentrated stock. So that's going to be our diluted solution. So V2, our final volume of dilute, will be 100 milliliters, and the concentration will be 0.45%. The initial concentration is 0.90%, and so the one thing we don't know is V1. Okay, concentrations, percentages. Is that okay? Do we need to change that to something else? Well, it is perfectly fine because both concentrations are in the same unit, right? They're both percent. So when we set up our equation, we're going to have something with a ratio of concentrations and the units will cancel out. So we do not have to convert them to anything else because they're both the same. So starting with the general equation and solving for V1, we have C2V2 over C1. And plugging in 0.45% times 100 milliliters divided by 0.9% is 50 milliliters, right? And you may have even like guessed at that, right? Because you see that you have the concentration cut in half, right? And so you only need half as much volume, or you need double the total volume. So this question is not quite done yet, though, right? Because it actually asks, how would you prepare? It doesn't say how much of the stock solution do you need. So we would say something like, we will take 50 milliliters of the normal saline solution and add it to a 100 milliliter volumetric flask, and then fill it up to the line with water. So we'd have 50 milliliters of normal saline and 50 milliliters of water, right? So we would have a total of 100 milliliter solution, um, diluted by a factor of 2 from normal. Okay, this is it. This is the last slide, and then we're like done with this section. So one part, and that's it. Okay, here's a multiple choice question. What is the molar concentration of a lidocaine solution prepared by diluting 5.0 milliliters of a 1 molar lidocaine stock solution to the mark in a 25 milliliter volumetric flask? So answer for yourself. And the answer is 0.2 molar. So maybe conceptually you could say, well, look, we're going to go from 5 milliliters to 25 milliliters. So the volume will increase by a factor of 5. So the concentration must decrease by a factor of 5. And so we get 0.2. Or, right, we can actually solve and we should end up with the same effect. So 1.0 molar, and then we now have that ratio of 1/5, right? 5 milliliters over 25 milliliters. So 1/5 times concentration is 0.20 molar. Okay, that's it for dilution solution. I encourage you to check out more practice exercises in the text and go find these problems on Sapling. And we'll see you next time.